And continuing. Okay, so by the way, I have this system restart thing going. Let's see, my mouse is dead, but yeah, notice how I have this icon up here, so things can go possibly wrong in the middle of this recording, but we'll see how it goes. I'm trying to move my mouse, but anyway, let's see, it's like dead. Maybe if I use my wireless one, but my pen works. It's just I'm not that coordinated. Ah, okay. So my wired one doesn't work, but my wireless mouse works. Uh, it's a ASUS mouse, so this whole computer is pretty much an ASUS computer. So it's one of those. It was a pre-built ASUS, and then I threw other stuff into it and changed the case, and yeah, it's Frankenstein now. It's been needing an upgrade. Okay, so yeah, where are we at? Oh yeah, using pointers for data entry. Cool. So let's read this and then let's get ourselves oriented. So, using pointers for data entry. You already know how to get the user to enter a string from the keyboard. You can do it with the scanf function. So this is basically you're declaring an array of 40 characters as name, and then we call scanf for 39 characters from the user, telling scanf to store whatever input the user gives to name. Okay? How does scanf actually work? Well, it accepts a character pointer, and in this case, when you're passing it an array variable, and in this case, you're passing it an array variable, okay? By now, you might have an idea why it takes a pointer. Because the scanf function is going to update the contents of the array. Functions that need to update a variable don't want the value of the variable itself, they want the address. So that's cool. So again, when we actually do a scanf for user input, I think this is basically going to be our name variable here. So let's just have this array as name. And when we do scanf, we want to actually pass in this so that it can actually go all the way to the first element and start putting in the characters as necessary. You don't want to give it the value itself. Like, for example, you want to dig in, because then scanf would only update the first value in this case, I would assume. Okay? So that's the reason why if we take a look at, let's say, scanf cpp reference, let's actually format this, favorite this website. So let's do C, and then we'll have a C reference here. So C reference, we'll just copy that and put it in the notes. So, oops. 2024. I don't know, it's like 17th now. I don't even know why I named it. It doesn't even matter. Okay, so okay. Anyway, so this is a website that is pretty much like all reference to API. So basically, all the functions we can call in from the standard library of C. So I'm guessing we want to look at input output, and when we're here, this is basically all the things in stdio. So if we were to, let's say, control F, find scanf, we'll be brought to here. So let's go into here, and you'll see that there's a bunch of definitions here. And we're looking at scanf here. So notice how it takes in, let's see, a pointer, right? So the format, which is going to be the string here. So that is a pointer to a character. This is just equivalent to like an array of characters. And then after that, let's see. I think the dot 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 means what? Reads the data from stdin. Okay. So that would mean some other character? Let's see. So this function happens to have been deprecated since, I guess, C11 updated a lot of things. Huh. So all these are formats. And then I guess we're looking at this one? scanf? Or, let's look at scanf. Right here. Yeah, so it does take in a memory address, so that's how it really is. And I think if we looked at, I guess if we were just look at what Visual Studio shows, I'm just basically trying to learn how to read these things. And hover over, okay, we have the format and then dot dot dot. Meaning it's from anything. SCDN, it could, so it's like, I guess, user input in this case. That's what it means. Okay. Huh. All right. So entering numbers with scanf. So how do you enter data into a numeric field? You do it by passing a pointer to a number variable. So it's the same thing, right? So instead of the reason why we need ampersand for this int is because we want to pass in the address to the int. Back up here, this is an array, right? And actually, when we refer to an array like with its label like this, it's actually passing in the base address. So it's still passing a pointer, and this is passing a pointer here too. Because you pass the address of a number variable into the function scanf, scanf can update the content of the variable. And to help you out, you can pass a format string that contains the same kind of format codes that you pass to printf. Okay? You can even use scanf to enter more than one piece of information at a time. Oh, that's interesting. Oh, cool. So if we had two variables here, we can ask the user to enter two things at once. And I think how it is done is through separated like white space. So it'll kind of delimit by the space. Let's actually write a little program. I want to code, so let's write a little program to demonstrate that. Where's my Visual Studio Code? Ah, right here. Let me respond to something. Okay. Okay, so let's create a project. Let's do scanf demo. And let's create main.c. And let's get rid of that. And let's just write our basic program. Why keep doing that? Okay. So that's our template that we're probably used to writing right now. Our standard main function. Okay, return 0. And let's begin. So let's write a program that will receive, I guess, first name, last name, and an age. So we'll have three things that we'll want. Let's see how this works. So we'll follow something like this. Let's say that the first name and last name can't be more than maybe 80 characters. And then the age will just be some sort of integer. So let's just follow this and we'll say, okay, let's declare a first name array. which is 80 characters. Okay, let's also declare a last name array. Let's call it 80 characters too. Then let's declare, can I move this down a little? Okay, let's declare an age. Okay, let's ask the user, enter the first and last name along with age. Okay, it's prompt, and then we will call scanf for 3 values. We'll take in, I guess at most 79 characters. Is that how it works? At most 79 characters, and then we'll take in at most 79 characters here, and then 79 because 80 would, the last one would be the no terminating character, and then we'll take in the number. This is how it works. And then I guess it's just gonna be first name, last name, and then so these are to our pointers, right? Because they're just basically the base address to these arrays. For age, we can't be tricked, so we're gonna give it the address to that integer, and let's just print it out. So we'll do first %s. So we'll get the user input. Yeah, so get the user input. We'll put in the 79 characters into first name at max, 79 characters into last name, and then the number into age, and then we can just print it this way with a new line, and then we'll print first name. Let's kind of adjust this a little bit. First name, last name, and then age. Something like this. So this one here, last name goes to here, age goes to here. So simple program, simple prompt. Okay, let's compile and see what happens. Where we, this one will be scanf demo. See what happens. GCC main.c. Okay, run a.out. Enter the first and last name along with age. Okay, Bill Russell. I think he's like 90 years old by now. Cool. So first Bill, last Russell, age 90. How old is Bill Russell? He's a basketball player. Bill Russell. Oh, he's passed. Rest in peace. Okay. Ooh, he died at 88. Oh wow, he is 90. He would have been 90 this year. He's one of the greatest basketball players ever. Played for the Boston Celtics in the 50s and 60s. He won a lot of championships. So I think there was like one time where his team won 10 in a row for the NBA. So yeah, he won. I think at some point, like the NBA MVP trophy was named after him. It was called the Bill Russell MVP award. So yeah. Yeah, I see the green here, one NBA championship. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 championships. He had like 25 rebounds per game. That's like unheard of. Okay. Yeah, so that's a basic scanf. So for scanf, we pass in pointers to tell scanf where we want to store the data from user input. Okay. Oh, warning. Okay, be careful with scanf. There's a little problem with scanf. So far, all of the code you've written has been very carefully put a limit on the number of characters that scanf will read into the function. So for example, you only want to receive 39 characters into name, or you want to receive only 2 characters in the card name. Okay, so apparently this is a security implication with all of this. Interesting. Why is that? After all, scanf uses the same kind of format strings as printf. But when we print a string with printf, you just use %s. Well, if you just use %s in scanf, there can be a problem if someone gets a little type happy. So for example, let's declare a food array of 5 characters, and then we want them to enter in a string that will go into food. But we're gonna go over that limit. It looks like the user is gonna put liver, tangerine, raccoon, toffee, and then when we print this out, we actually get a segmentation fault, which is usually like a memory error. Okay, so the program crashes when the user does this because we didn't put a limit of what we want to receive. The reason is because scanf writes data way beyond the end of the space allocated to the food array. That makes sense. So if our scanf is expecting, let's say this food is going to be 5 characters. Let's just do this. 1, 2, 3, 4, 5. Okay, so food starts here. This is like the safety, right? Like, so food is all the way down here, right? And if we don't put a limit, when scanf starts to drop characters in, it's going to go way beyond the limit and potentially E, F, G, H, apparently going over the limit and into other places in memory. And this could be other variables too. This could be like, first name, for example. And all of a sudden, first name is like overwritten, just potentially, right? So if you don't have a limit, you don't put a limit to the length of the capacity of that array, you could potentially run into these out of bound issues. So we call those buffer overflows apparently. And C doesn't stop us from doing this, right? So if you forget to limit the length of the string that you read with scanf, then any user can enter far more data than the program has space to store. Okay, we just saw that. The extra data then gets written into memory that has not been properly allocated by the computer. Now you might get lucky and the data will simply be stored and not cause any problems. Yeah, I've been lucky a lot for like some of the bad stuff that I've done in C. But it's very likely that the buffer overflows will cause bugs. It might be called a segmentation fault or an abort trap. But whatever the error that appears, the result will be a crash. So we can totally crash our own program here. We did this. And we'll save. Okay, so we won't even have a limit on first name. And I think most of the time it should work. So we won't have a limit here. Okay, S, 79S, and D. So if I did just something normal, right? Michael, Jordan, let's say, how old is he? 50, 61? 61? Is he 61? Something like this. That's fine. But let's say now I go over 80 characters. This has to be over 80 characters. And then I'll just generically type last name with an age. Okay. Look. First, last, because since these two were declared consecutively, it looks like I overwrote last name with all these characters. It's so funny. That's interesting. And then age is now 0, even though I specified 78, because I'm starting to overwrite places in memory, and now it doesn't even make sense. Huh. Is that the behavior? Let's see. If I were to do this again, and I'm like 1, 2, 3, 4, 5, 6. Actually, you know what? Let's make this shorter. I'm not gonna. Yeah, let's make that shorter. Okay, 1, 2, 3, 4, 5, 6, 7, 8, and then 9, 10, and then 1, 2, 3, 4, 5, 6, 7, 8, and then 8. Oh, this is 99. Cool. So that worked. Lucked out there. How about doubling that? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay. That's fine. How about if I did that? Okay. So they're right. Most of the time it'll work, right? So if I did this, okay, we're starting to run into issues. So cool, I guess. Our program's not crashing though. So I think it'll be really hard. Maybe because I have a lot of memory in this computer? Huh. Okay. I'll take it, but let's fix that. Basically, you don't want this. It causes a lot of weird bugs, so you have to you have to make sure that you don't do a buffer overflow error. Okay. FgetS is an alternative to scanf. Oh, that's guess that's good to know. Let's read it. So there's another function you can use to enter text data, fgetS. Okay, fgetS. It's just like the scanf function. It takes a character pointer, but unlike the scanf function, the fgetS function must be given a maximum length. So that's like a required right here, a required parameter, I guess. Interesting. So the signature is the character pointer, so the destination where you want the user data to be in, the variable, right, the array, the size, the maximum size of what you want to take in, and then standard in, which is coming from the keyboard, so coming in from the user. And we'll find more about this stdin thing later, apparently, in the book. Okay, so that means you can't accidentally forget to set a length when you call fgetS. It's right there in the function signature as a mandatory argument. Also notice that the fgetS buffer size includes the final null character, so you don't need to subtract 1 from the length as you do with scanf. So give the maximum size, and it'll also take into consideration the null character. So before we were like inputting 79 here to say, hey, let's only take in 79 characters because we want to save the last character for null character. Well, for fgetS, you don't need to worry about that. It'll just know how to do it. Okay. So what else do you need to know about fgetS? Using size of with fgetS. So the code above sets the maximum length using the size of operator. Be careful with this. Remember, size of returns the amount of space occupied by the variable. In the code above, food is an array variable, so size of returns the size of the array. Okay, if food was just a simple pointer variable, the size of operator would have just returned the size of a pointer, which is the size of the memory address. Okay, if you know that you are passing an array variable to fgetS function, then using the size of is fine because size of on an array will give us the length of the array, so the number of characters in the array. So if you're just passing a simple pointer, you should just enter the size we want. So it's safer to just enter in explicitly the size that we want. And I think that's what we'll do. Yeah. Tales from the Crypt. The fgetS function actually comes from an older function called getS. Even though fgetS is seen as a safer to use function than scanf, the truth is that the older getS is far more dangerous than either of them. The reason? The getS function has no limits at all. So it just straight up does this. You declare 10 character array, you could just, I guess, infinitely put stuff. GetAs is a function that's been around for a long time, but all you really know is that you shouldn't really use it. I I, I think it's just don't use it, right? All right. I mean, this is just like a comparison. Um, yeah, like I guess what to use over the other. Um, so one thing to know about this one is that uh, scanf allows us to enter more in one field if we are passing them and the user is entering white space in between. But getS just reads until what? Until the new line, I think, once you hit enter. And scanf gets hit badly when, okay, there's spaces and strings because scanf will assume that that's going to be for the next input. And then fgetS will just read the whole thing. Okay. So for structured data with several fields, use scanf. If you're entering a single unstructured string, then fgetS is probably the way to go. Sure. Okay, let's do a demo. Let's do fgetS. It's like the more we program, I guess, the more we get used to C. So far, it's been pretty simple, except for the pointer stuff. Let's see. Include. I didn't mess that one up. Oh, I did. stdio.h int main int argc character pointer argv. That's for our arguments. Okay. Now, let's just ask for some input. I guess we can do the same thing. We can probably try to do character first name. Let's keep it at 80 characters. Character last name. Let's keep that at 80 characters. And let's do age. Okay. And then what are we doing here? I guess we're gonna do printf. Please enter your first name, last name, and age in different lines. I think that's what it is. So yeah, and then we'll do fgetS. And what's the signature again? It's the string, the pointer, I guess, string, and then the number of characters we want to get, and then the stdin. They said stdin for character or for just keyboard input. Okay, so first name, we want to get the first name. Then how many characters we want to get maximum? 80. Because we had to do 80 because null terminating character is also included. And then the stream, which is stdin. Okay. And then I guess last name will be here too. 80 stdin. Now this one's interesting because now if we do age, this is probably not going to work. If we did something like this, and then we say maybe 3 maximum for like 3 digits and an stdin. This is actually going to return, I guess, a pointer to an int, and I'm not sure that's going to work, but let's see. So let's print out first name. I've been through this. Let's keep it in different lines. First name, it's going to be %s. Last name, it's going to be %s. And then age is going to be %d. And then we're going to have first name, last name, and then age. Just the values, all values. So we'll hit save, we'll compile, and then test. So gcc main.c. Here we go. Warning, passing argument 1 of fgetS from an incompatible pointer type. So we're trying to pass in a pointer to an int, which doesn't work because fgetS expects a pointer to a character array. So we know that, I know how to solve this, right? Like, why don't we just create an array of 3 characters, each representing digits, and then we'll call this a to I helper to turn our string into an integer. We could do that. So maybe character age could be 3, and then we'll take an age, so we'll take an age here, and we don't need a pointer anymore because that is automatically a pointer now since it's an array. And then when we're printing this out, we can convert this to a number, a to I. And that takes in a character pointer, which is basically our array as it is. Was I looking at the right thing? Let's see. How do I go? Actually, let's take a look at. Oops. Let's take a look at the website. So we can do something like a to I. And yeah, it does take in a character array or a character pointer, which is our array. That gives us back an integer. So cool. So this is seemingly right. So let's see how that works. A to I. Implicit declaration. Oh, we need to include stdlib. That's why. It doesn't know what a to I is. I think it'll even hint. It says. Oh, it doesn't even hint. Okay. Include stdlib.h. Nice. Okay. Enter first name. Bill, Russell, or no. Wait. Let's try this. Bill, Russell, and 78. Where was it? He was 90. Okay, first name, Bill, last name, Russell, age. Okay, let's fix that later. There's something wrong with our input, but I think y'all might know why. But what happens if I try to do it like scanf, where I input Bill, Russell, 90? So it's still asking us for input, right? If I did this, it'll think that the first name is Bill, Russell, 90. So, fgetS seems to be new line delimited. So we can probably write that main point in our docs, right? So note, fgetS is new line character delimited. And then while scanf is going to be white space delimited. Okay, so when we actually receive input from fgetS, notice, and I'll just demo it again. Bill, Russell, 90. Notice how we have like a new line down here and a new line down here. Because actually when you call fgetS, even though it's new line delimited, it's also going to include the new lines here. And so we have to clean that up, right? I could just talk about it now. I think eventually the book will go through it, but just for sake of I want to be able to make this clean. There is a built-in library called string.h that allows us to do a lot of string manipulation. And basically how it works is there's a helper called string character, and let's just take a look at it, what it is online. So it's strchr. strchr Well, it basically finds the first occurrence. So given some string and some character, right? Some string and some character. So this is a character pointer, so that has to be a string. Int character means that, well, I mean, character is a number, so it's defined as an int. So it finds the first occurrence of character in the null terminated byte string pointed by str. So it finds the first occurrence of the specific given character inside this str string, and it will return back, I guess, the pointer to that um, part of the string that was found. So in this case, if we wanted to find, yeah, pointer to the found character in string. So let's say here, if we had a string, uh, let's say food, and then here's our string, I guess, str, and then ch is going to be o. If we were to find, and I should probably do something like this. That's going to be whatever we get from scanf. If we want to find O, actually what's going to be returned is this one, result, right? So we'll get result pointing to this string here, or this character here, and then we actually can go and get the rest of the string down here. So it takes us to the location of the first occurrence of that character. That's what strchr is. So knowing that, I think what we can do is if we had the same string, and then just say FOOD new line null terminating character, we can do something like this. This is str. We could find basically strchr on s new line character to find the location of that new line character. And this will actually take us to here. Okay? And then from here, this will be, let's just call it result. Well, that is a pointer, right? This is a character pointer. So what we can do is we can just update whatever is pointing by result to the null terminating character. So this becomes this, and we can kind of get rid of the new line character, because whenever we print out the string, we only go all the way up until we find the null terminating character. This stays the way it is, right? Because we don't want to mess with it anymore. So we've early terminated the string. So this is how you actually, I think I gave an example a few days ago where I basically lopped off part of the string by just setting that location to a null terminating character. This is exactly the same concept. So we can easily do that here in code. So we can do something like this. We can do character pointer, new line, occurrence in first name. We do strchr and first name, and then the character we want. We can then, once we have this, we can just update. Remember, update the value pointed by that pointer, which means we have star on the left side to be the null terminating character, because at that point, once we found the occurrence, that this here will actually point to that occurrence of the character. Then we can just overwrite that value with the null terminating character. Similarly, we can do it with the last name too. So new line occurrence last name is going to be strchr last name, and then the new line character. We want to find a new line character, and then we want to update that. So new line occurrence last name is going to be, again, null terminating character. So notice we're not actually modifying, right? We're not modifying the first name and last name directly. We're modifying it indirectly by getting the addresses to certain characters in that string in memory and then just altering it there. We're just poking at it without even touching the variables. So we can do the same thing again with the age. New line occurrence at age is going to be strchr age, because age is now a string, right? So it's a string now, not a number anymore. So new line occurrence age is going to be null terminating character. So we've kind of just truncated that part out. And I think now these here will actually have a modified string because we poked at their memory. So we were to compile this again and run. If I said Bill, Russell, 90. Uh-oh. Segmentation fault. What happened? Let's see. Is it because what? What would be the problem? Is it because it's finding it elsewhere? Let's see. I know this should work. Is it because null character is something else? Actually, let's find where it fails. I have a feeling it could be maybe here. Huh. It could be our age. How are we doing? Why would does our age have a new line? Does our age have a new line? That's interesting. So let's look at something here. What is the return value? Let's say we wanted to find the occurrence of a character inside a string. Okay. Now using the strchr, let's look at the documentation on the cases where the character may not exist inside the string. Maybe that'll give us a clue. So let's see here. Return value. Pointer to the found character in string, which is our assumption, or no pointer if no such character is found. Huh. So maybe age doesn't have a new line after it. Why don't we check that? So if new line occurrence, let's just do this, equals null. Let's just have a printf. Age is null, or no, age does not have a new line character. Okay, so this is obnoxious, but that'll actually give us a hint. So, oops, we don't need that. We're checking the pointer, we're not digging into the value. So if the pointer is null, which is what this is supposed to return, if there is no occurrence of new line character, we want to print out age does not have a new line character. So let's check it out. Okay, so I'll say Bill, Russell, 90. Oh, of course. F get S is delimited by new lines. Okay, so age does not have a new line character. So now we get a segmentation fault because apparently the age here doesn't have a new line. I guess that's like a case for, at the end of the input or something. So, well, if it's null, then, or we only want to do this part if we actually don't have a null pointer, right? So I would say let's just only do it if we find that there is a new line character, meaning that if our pointer received by strchr is not null, meaning that there is a location where there is a new line, we want to update that to a null terminating character. And I believe then this should work pretty nicely. So Bill, Russell, 90. So that works now. So we have a clean check on this condition. Now I argue now that this same issue could happen for these two too, which is why the documentation said or a null pointer. So I think we should do the same for these two too. So if new line occurrence on the first name is not equal to null, meaning that we do have a new line character occurring, we should probably then update to not have a new line character. Same thing for this, because what if there wasn't any new line character? We'll still crash in this case. So here, and we should have some safety now. Cool, so that's how we check for occurrences in strings. See if it still works. Yeah. Bill Russell 90. Cool. How about if we did this? Nothing. Okay, that's fine. I'm okay with that. So it all works. Cool. We learned fgetS. We also learned strchr. That's like the string manipulation is so powerful because it's gonna allow us to do a lot of interesting projects in the future. So yeah. Let's continue on. Okay. Anyone for a 3-card Monte? In the back room of the Head First Lounge, there's a game of 3-card Monte going on. Someone shuffles 3 cards around and you have to watch carefully and decide where you think the queen card went. Of course, the Head First Lounge, they're not using real cards, they're using code. Here's the program they're using. So, okay, sure. This code is designed to shuffle the letters in a 3-letter string. So, given this string, which is kind of like an array, we set the A card to be the third element, 0, 1, 2, right? 0, 1, 2. So cards 2. So that should be like K or something. And then we start to swap stuff around, but we're swapping cards. We're swapping cards. So we're swapping elements inside these cards. Okay? The program switches the characters around and then displays what the string looks like. So then after a while, we're going to just display what's the order of the cards. Because we're supposed to be shuffling. This is like shuffling code right here. So like assign cards 1 to cards 2, assign cards 0 to cards 1, assign, it's like that, right? So the players place their bets on where they think the Q letter will be, and then the code is compiled and run. Boom! There's a memory problem. Oh no, it seems like there's a problem with the Card Shark's code. When the code is compiled and run on the Lounger's notebook computer, this happens. Bus error. So that's like equivalent to like a seg fault, right? Like segmentation fault, or yeah. So bus error is also a memory error in this case. So what's more, if the guys try the same code on different machines in the operating systems, they get a whole bunch of different errors. Kapow, whack. So I'll give a hint. I kind of know this issue. It's what I got bit by a couple days ago when I tried to show you guys how to update a character in a string that was already kind of hard coded as a pointer. So it was something like I remember it was like something like const or not const JavaScript mode. Character star my string. I think it was like something like this. I would try to do hello. And then I think I was like trying to do something like my oops. I think I was trying to do something like what was it? My string I think it was like I was dereferencing. No, I was dereferencing for an update, and I was like trying to do something like this. Update to the character Z or something like this, and then I got a seg fault. It's like seg fault. I tried doing this and then I got burned on camera, right? And I realized, oh, I think I know what's wrong. So I think this is gonna be the explanation. Um, so I think it was in the to do too. Let's see. Sorry, I want to go back to this mistake because it's a mistake that everybody will make. And no matter how like aware you are, it's bound to happen. I think it's like in pointers test 2, maybe. Yeah, this one's like, why doesn't this work? So we had hard coded the string here, and then we tried to set the last index here to be X for Dex. And then boom, we had a crash, right? So um already we can kind of tell what's wrong. I'm gonna tell you the string can't be updated. Okay? And that's true, the string can't be updated. So why? String literals can never be updated. A variable that points to a string literal can't be used to change the contents of a string. So this becomes a constant. When you declare a string literal like this, not an array, but like a pointer to some block of memory that has characters, this is kind of permanent. So kind of. It is permanent, really. If you create an array from a string literal, then you can modify it. So the reason is that it comes down to how C uses memory. So in memory, the character pointer of cards that starts at J, so ending up with JQK. So to understand why this line of code causes a memory error, we need to dig into the memory of the computer and see exactly what the computer would do. So the computer loads a string literal, so it'll load this right here, JQK. When the computer loads the program into memory, it puts all of the constant values, like the string literal JQK, into the constant memory block. This section of memory is read only. So right here, it ends up being here. So this part you can never change in this memory model. The program creates the cards variable on the stack. Okay, so this one here is in the stack, but then it points to this because the compiler is going to save this into constant memory. Okay, the stack is a section of memory that the computer uses for local variables. Variables inside functions. The cards variable will live here. The cards variable is set to the address of JQK. The cards variable will contain the address of the string literal JQK. String literals are usually stored in read-only memory to prevent anyone from changing them. Okay? The computer tries to change a string. When the program tries to change the contents of the string pointed by the cards variable, it can't. The string is read-only. I can't update that, buddy. It's in the constant memory block, so it's read-only. So the problem is that the string literals like JQK are held in read-only memory. They are constants. So if that's a problem, how do you fix it? If you're going to make a change, if you're going to change a string, you should make a copy. Okay. The truth is that if you want to change the contents of a string, you need to work on a copy. If you create a copy of the string in an area of memory that's not read-only, there won't be a problem if you try to change the letters it contains. But how do you make a copy? Well, just create the string as a new array. So just make a new array like this. So cards is not just a pointer, cards is now an array. It's probably not too clear why this changes anything. All strings are arrays, but in the old code, cards was just a pointer. So remember, this was just a pointer. This was a pointer to this string in memory. But now what you're doing here is you're allocating a block of memory, right, in the stack with JQK. That's a huge difference. This was a pointer in the stack. You created a pointer in the stack because the code The code being all the way up here, right? It's in the main function. So when you declare stuff inside a function, it becomes part of the stack, right? So when you declare this, this is a variable that lives in the stack and points to this thing in memory. Whereas the subtle array notation, you're creating the variable in the stack too, but it's like a block of memory in that stack. So now you populate it with JQK in that stack memory. So, so it's probably not too clear why this changes anything. All strings are arrays, but in the old code, cards was just a pointer. Yep. In the new code, it's an array. If you declare an array called cards and set it to a string literal, the cards array will be a completely new copy. The variable isn't just pointing at the string literal. It's a brand new array that contains a fresh copy of the string literal. Okay, to see how this works in practice, you'll need to look at what happens in memory. So before we do that, let's read this. Cards array or card star? Or pointer to cards. If you see a declaration like this, what does it really mean? This is an array of characters. Well, it depends on where you see it. If it's a normal variable declaration, then it means that cards is an array and you have to set it to a value immediately. Okay? But if cards is being declared as a function argument, it means that cards is a pointer. So these two are equivalent. So you just gotta remember it. When you're declaring stuff inside a body, it's an array, but if it's in a function signature, it's a pointer. Okay. So here's the explanation on why this works. So we've already seen what happens with the broken code, but what about our new code? Let's take a look. So the computer loads the string literal, JQK, as before. When the computer loads a program into memory, it stores the constant values like the string JQK into read-only memory. So here, constants. Then the program creates a new array on the stack, right here. When we're declaring an array, the program will create one large enough just to store JQK string, 4 characters worth. So this is where the cards array is going to point to. The program initializes the array, but as well as allocating the space, the program will also copy the contents of the string literal JQK into stack memory. So the difference is that the original code used a pointer to point to read-only string literal, but if you initialize the array with the string literal, you then have a copy of the letters, and you can change them the way you want. So he changes it to, so it's not really a copy, you're just giving the contents of that array. Like they keep saying copy, but nowhere here they're actually copying anything. So right here is the fixed code. Okay. So one way to avoid this problem in the future is to never write code that sets a simple character pointer to a string literal like this. There's nothing wrong with setting a pointer to a string literal. The problem only happens when you try to modify a string literal. Instead, if you want to set a pointer to a string literal, always make sure you use the const keyword. This way, if the compiler sees some code that tries to modify the string, it will give you a compiler error. Oh yeah, because if we did the old way, right, and it wasn't const, that's why we were able to actually compile and run it, because nothing stopped us. But I bet if we did the const character, then the compiler will give us an error and we can't even compile to begin with. Okay, well, I'm getting tired, so I'm gonna stop here, and then we'll continue tomorrow. I think we got a lot done today, so yeah, I'm gonna check in the code. So it's something I always forget to do. So we have a few things. So I'm just saying git add ... Oops. Just that. Okay. I went from try to make a meaningful commit message to just adding stuff. But yeah, well, we'll see how much do we have left here. Oh, we're almost done with pointers. And then we're gonna go to strings. So that'll be fun. Okay. Let's try to finish and go into strings tomorrow. All right. See ya.